A very warm good morning to one and all present here. Sagar Institute of Science, Technology and Engineering, SISTEC E Ratibad campus is very much delighted to present and to conduct a workshop on the title Prototype Process Design and Development under the umbrella of IIC, that is Institutions Innovation Council, SISTEC E Ratibad campus, Bhopal. Dear friends, this workshop is headed by Dr. Ashutosh Shukla. He is Assistant Professor, School of Management, SMS, Varanasi. Dear friends, today we are glad to share this online platform with our dignitaries, and they are Dr. Manish Bilore sir, Honorable Principal, Sisteki, Ratibad Campus, Bhopal, Dr. Ashutosh Shukla, Assistant Professor, School of Management Studies, Varanasi, and he is the expert lecturer of the day. Professor Ashish Singhal, President IIC Sisteki, Ratibad Campus, Bhopal, Dr. Vibha Srivastava, Vice President IIC Sistek E Ratibad Campus Bhopal and Dr. Ayush Srivastava, Area Coordinator IIC Sistek E Ratibad Campus Bhopal. Dear friends, this workshop is going to be headed by the eminent professor Dr. Ashutosh Shukla. It is my privilege to introduce him to all of you. Here is brief introduction. Dr. Ashutosh Shukla is assistant professor from School of Management Studies, Varanasi, and Sir holds PhD in management from BIT Mishra, a renowned institution of India. His research areas includes organizational behavior and human resource management. Sir is having 14 years and more than 14 years vast experience in education, academics and consultancy. Now it is my privilege to invite and request Honorable Principal Dr. Manish Bilore sir for the opening note of this session. Principal sir, over to you please.
Thank you, Pankaj sir, and good morning, everyone. Also, a warm welcome to Dr. Ashutosh Shukla to our Sistek Ratibad campus. I wish you could have visited us in person, physically, but then unfortunately it's not possible because of the current situation. And in today's session, I would like to request you for a promise that you would definitely spare time to visit our campus at Ratibad. It's such a beautiful campus, a green campus, a very, very big campus. And not only the campus, but then I'm sure you will be happy to meet all of us, know about the culture that is prevailing at SISTEC, know about the academic and extracurricular and co-curricular activities that we have been practicing at SISTEC. So I'm sure this is the first meeting, but then this is definitely not the last meeting, and we'll have a long-term bonding together. So a warm welcome to you, Dr. Shukla, to SISTEC, and also my congratulations to the IIC team of SISTEC, Professor Ashish Singhal, Professor Pankaj Sharma, Dr. Vibha Srivastava, Dr. Ayush Srivastava. You have been doing a great job because of the simple reason that with this platform of Institution Innovation Council, you have been able to gather the students, you have been able to motivate the students, and you have been able to bring them up, bring all of them, rather most of them, to the next level of innovation. You have, I've seen you have motivated them, you have guided them not to restrict up to their final year projects, but to go beyond that, to think beyond that. How can their final year project be eligible to compete on a national level, on a very, very competitive level, and also how to make it user friendly and a community friendly or a society friendly project, not just a final year or major or minor project, which is, I mean, the sole purpose of the project would be to gain some marks from the university curriculum. So this is a good job, this is a good platform, and your team is doing good. My best wishes to all of you. Secondly, it's also important to gather people from the outside world. Why? Because we think, and it's not bad to think like that, that we are definitely having few restrictions, few limitations of thinking, of implementation, of planning. And therefore, people like Dr. Shukla and a lot of experts that you have gathered on this platform are definitely contributing to as far as innovation is concerned, as far as new development is concerned, as far as students' growth is concerned. So I'm sure with this, all of us will be definitely do more for students, do better job for students, so as to make them better citizens, better engineers, better technocrats, and better innovators in the time to come. So my best wishes to all of you. And once again, special thanks to Dr. Ashutosh Shukla and a warm welcome to him at the platform of SysTech Ratibad. Thank you very much.
Thank you so much, sir. That was indeed a wonderful opening remark. And we all have received blessings from your side, dear students, are also with us in this online platform. Now, before we proceed to the today's workshop, I would like to invite and request Professor Ashish Singhal, sir, President IIC and HOD of Electrical Engineering Department, Sisteki, Rathiwar campus, for enlightening us regarding this workshop. Over to you, Professor Ashish Singhal, sir.
Thank you, Pankaj sir. Am I audible right now?
Yeah.
Okay. Thank you so much, Pankaj sir. Respected principal sir, uh, my teammates of Sister IIC, and most eminent speaker, Dr. Ashutosh Shukla sir, Professor SMS Varanasi. I, Professor Singhal, President IIC, Sagar Institute of Science, Technology, Engineering, Bhopal, welcome you all. This is a learning workshop which is on the prototype process design and development under the banner of the IIC at Sistek Bhopal. IIC is known for the established to the systematically foster the culture of the innovation among the student across the various departments. As far as the Ministry of Higher Education is concerned, and they have established the IIC among the selected higher education institute across the India during 2018. The main focus of the IIC is to encourage, inspire, and nurture young students by supporting them to work with the new ideas and transform into the prototypes. Actually, that prototypes might be of final year projects. It certainly comes in the future with the invention and major startups. Now, I would like to say something about the objective of this particular workshop, why we organized. Those students who have connected right now, they will be able to understand the process to transform the ideas into the valuable design. They can be understand the process that what are the keywords to select our project and prototypes. Third, very much important, that is the process of journey from prototype to the patent. So these are the main objectives of this workshop. I hope it's clear to all the students so that they can understand well the whole workshop easily. With this word, I welcome once again to all the dignitaries on the behalf of the IIC Sister E. Thank you, Pankaj sir. Thank you so much. Over to you.
Thank you so much, sir. That was really a wonderful speech from your side. Now, we are inviting today's guest, today's expert lecturer, Dr. Ashutosh Shukla, sir, to start the journey of this session. Over to you, Dr. Shukla, sir.
Thank you, sir. Um, I would like to thank all the members of SysTech, especially to Principal Sir and Dr. Ayush Srivastav, Pankaj Sir, Sharma Sir. Uh, it has been a wonderful association, and I will try to share something with all the students on the, especially on what is the need of that prototyping and how we should go about it. So let's get into this. I have- I think this is visible to all.
Yes,
Yes, sir.
sir.
This is visible.
Okay. Okay. So here we go. Uh, especially to all the students, it's all about beginning with an idea in a mind. So why do we want, I mean, the whole idea is about harnessing the creativity. Okay. So when we look into the various creations of this world, what we find is that there is a kind of energy which wants its expression. So whether it is scientist or whether it is an engineer, there is some kind of creative energy which is finding its manifestation. And this is where the whole journey begins. So we have to start with beginning with an idea in mind. Okay. So everyone, irrespective of the field, we will see that there are bright flow of ideas, things which are working, and things which exist in some form, some abstract form, which nobody knows how it will look like, how it will work, whether it will have any utility to this or not. But idea is most important thing. And from this idea, how we get transform this idea into reality is all about the journey of prototyping, and then from invention to innovation. So my whole idea of this workshop would be to equip a student, to make them understand that there are certain tools which they could apply, and these tools are practical, and they could simply use it. It's all wisdom which is there for centuries with people, and there is a constant research which is ever sharpening it, with giving its new dimensions, new edges to it. So let's try to look into that. Let's begin with a simple idea: how to fly. Now now this idea in the year 2021, when people are going to, when we see that lot many corporations are moving to space fly, they are aiming at Mars, or they are aiming at going beyond. Now think about, let's go back and say during the year 1905, and it was like when Wright brothers invented the aeroplane. So if you could see, this was the picture on the top. If you could see, this is what the first aircraft looked like, and it was a big thing because people aspired for, that flying thing was there for generations, and we have seen it in lot many books, in lot many historical, uh, what you say, text. We could see that people always aspire to fly. But and then there were experiments also. People came up with different ways to fly. So there were definitely balloon, and how to fly a balloon, and then there was whole lot of streams of thoughts which could enable one function, that is how to fly. And then if you could see that from here, which was in 1905, it was a plane which was invented by Wright brothers, but it took 30 years to actually arrive at MC Douglas, which is there in the lower picture, as you can see. So this, from here to here, it took 30 years. So what it means, so when an idea has been invented and it is been proven to work in laboratory, we call it as invention. Okay? Students, try understanding that when we see something working well in laboratory, we have our equations. Those equations are working well. They are, you can see that yes, it is leading to something. And but is it, can we replicate it on a meaningful scale? Perhaps not, because invention has not become innovation. And this journey from invention to innovation is where we have to discuss about prototyping. Why? Because invention will definitely make it possible that uh, the work, invention will make it possible that yes, there is some idea, we have arrived at something, but the work is not over. In fact, it has begun, because there would be a whole lot of challenges which are waiting, which are needed to be addressed, so that the invention should take shape of innovation. And I have never seen a more beautiful description or difference between invention and innovation as by Peter Senge, who is learning organization guru, belongs to Sloan School of Management, MIT. So when an invention can be replicated reliably on a meaningful scale and at a practical cost, it can be considered as innovation. So we have to look out for these keywords, that there has to be scale. The scale is involved, and practical cost. It should not be so costly, right? So again, as an engineer, the task of engineer is to solve problems. Engineering in itself is a problem solving discipline. People face problems, societies face problems, and who is there to solve those things? And so engineers, with their technical blend of mind, with with the use of the basic laws of nature, they harness those things, and then they were able to then they translate those things into an innovation. Like how you we would move from invention to innovation. So this is all about that, the beginning of an idea. So idea is the one thing. So from idea you move to invention. And yes, is there, when you say that I have got an idea, so prototype, and then I am moving to invention, and from invention to innovation. So this is a pretty big field. So when, where is the prototype appears? So you could say that yes, prototype could happen at two places: pre-invention phase and then pre-innovation phase. And you will see that more and more of pre-innovation phase is the area which you should actually target. As a student, I should suggest that you should look out for different angles, different things. So simply people are not trying different ways. We are so convinced about ideas that the world, what we see, how it exists, there is, we there are things which happen only certain way, and we are very very convinced about it. So we do not dare to think beyond. And this is the real problem. So, with this note, I am trying to connect invention, idea, inventing, innovation with prototyping. So, as an engineer, what is the main job? I will try to highlight some of the areas which which are borrowed from different fields. And let me tell you, the underlying logic remains the same. And the logic is that you are there to solve problem. So do more problem solving research. I will take an example of action research. What is this action research is all about? Although action research is primarily taken from management, and then you could see it that Kurt Lewin came up with this idea of action research, and he says that, you know, uh, it is about bringing a transformative change. What kind of transformative change is he is talking about? So try to understand that it involves an action evaluation and critical reflection. Try understanding. Look at these words, that you do, and you do not settle. You are not settled with something. You continue to evaluate and so that unless something stakeholder is attained, until and unless that thing happens, you do not stop, and you are always already in a flux, in a state of flux. You There are actions, there are evaluations, repeated evaluations, and critical reflections. So in action research, what people actually do, they definitely have some kind of problem, or they come together with a common purpose. So even if you are working on some engineering project which may be assigned by your faculty members, or you might have chosen a project on your own, there is some common purpose, that why you are collaborating. So, and you have to participate, you have to see that what all variables are involved. Okay, and then you have to move from one stage to another, that is constantly trying to see that what happens. There is a logic, and unfortunately we are living in a times when we have the power of AI, we have the power of 3D printing, and these two things, I believe, is the greatest game changer. You can simply, it has become much easier and cheaper these days, highly cost effective, to test your ideas, to develop those prototypes. And it is like a chain. You develop certain things, involved get into costly experiment, that how to manage that team workflow in your team. You have already won, you have already moved, your more than 80% of journey is over. Understand, this is all about collaboration, and it is all about developing reflection. So reflection is a very important thing. When you do something in a way, you want it, you expect it to behave in a certain way. There has to be some tracking mechanism at place, where you could see that, yes, it is leading me to some important plane, or am I moving in the right direction? This is what you have to see. So the more you reflect on that, what is the issue? Am I able to, how much successful I am? Is it like, and then can I quantify my success? Is it like 50%, 30%, 20%? Can I do that? And see, understand, if the more you are good at, better at measurement, because it's all about 3 M's. Remember this: meaning, measurement, and management. Meaning, measurement, and management. The better you could understand, define something, define it well, and then your ask your team members, okay, this is my project, this is how I defined it. Definition is clear to everyone, meaning is clear to everyone, variables are clear to everyone. Are can we quantify them? Can we just try to see that how these variables fit together, and then trying to, you know, understand, manage them properly. If you are able to measure it well, you could manage it well. Okay, so you will always find a correlation that ill there would be some issue with variables only. People do not define variables properly, that I have seen, and that is why they face trouble. And then there is, definitely there is a subjectivity to be addressed. But for you engineers, I would suggest that yes, there is a subjectivity to certain thing, but your job is there to make things in to define it in objectively. Okay, we always say that there is some kind of operational definition of something, so you have to move on, and from there you have to pick up things. Let's look into these two things. They all narrate the same logic. If you see, this is PDCA cycle, which is there in continuous improvement. And we say that it's an ongoing cycle of plan, do, check, act. And it goes on. It moves from one phase to another. You see that whether things are working well, you monitor it, you further improve it. And that thing again, okay, I originally began with 10 issues. Now 5 issues are resolved. Now I have to plan for my 5 issues. I again perform, I again check, I again act. And this is how the cycle goes on. Look at this in action research. It's plan, act and observe, reflect, and keep revising plan. With revising plan, you again act and observe, reflect, and you do it, making a spiral of things. So what I want to convey, that try to stick to the underlying logic which is being there with action research, or whether it is being with continuous improvement of PDCA cycle. The logic remains the same, and this is where I want to, where I am trying to emphasize. If you are trying to work on prototypes, you should not think like that, okay, just once you will develop a prototype and it is over. You have to see that yes, you have to run several prototypes. It could happen, and then there is no end to it. You, yes, you could uh, replicate your idea, you could make it workable, because any model will just remain a model, and it is just an abstract model. How it feels in reality, how will you know? Only through prototyping. So prototyping also follows the same logic. I am still extending the underlying logic in Six Sigma also. See, in Six Sigma, uh, these are the two popular ways in Lean Six Sigma approach, which talks about that define, measure, analyze, improve, and control. So basically, when you talk about processes and process improvements, you say that you define certain critical areas, critical success factors. Okay. What are my variables? How am I going to measure it? Okay, analyzing the variance, how to control the variance, that is to improve, and trying to stabilize the process. So understand this approach, DMAIC. And if you follow the second one, that is define, measure, analyze, design, verify, or validate, DMADV. This is, again, this is for your prototype only. Again, these are concepts which are used in different fields, especially DMAIC and DMADV is Lean Six Sigma approach. So in quality or in action research or in different fields, you see that the logic remains the same. I have to, if I am looking at some ideas, so where should I begin with? I should start with my variables, defining what I am trying to attain. Okay, so Wright brothers were trying to define that, yes, okay, the problem at hand is how to fly. Okay, so how to fly. So yes, and they could see that there is a design to it. Okay, so defining how to fly, and then they sticking to one basic, that okay, that birds could fly, but what about human beings? And there has been failures when people try to uh, pick some wing and tie some wing, and they try to jump from mountains. People did this, but what is the how that aerodynamics, what is the principle behind which is working, how to make that thing workable, that was the their starting point. So and then you move to measures, that what are the measures. Okay, so there is the problem of that how to structure it, because structure is everything, design is everything. So designing it properly, so that the objective objective is to fly, and how to make that thing happen, you have to work meticulously on different aspects which could enable an aircraft to fly. Okay, so you have to work on engine, you have to work on the weight, because if you would carry out a detailed analysis of what all factors are important, and if you could run um, that what are the critical components or most important things, you might be aware of Pareto analysis, where 80-20 rule is there. So 20% of the component are responsible for 80% of the solution, or 80%. So not everything, if there are 100 things which are attached to it, not have 100 things equally contribute to the problem at hand. You have to first define that, yes, there are some factors which are more important, or which have a greater role to play. So that is where you have to focus on. So if you simply, when you sit with your team members and you are deciding on developing a prototype, you first try to see that what all variables are there, how to get it done. Okay, and how this is going to help people. Is it going to add value? What kind of value addition will take place? Is it like just some kind of fantasy that I am just subscribing to? It's not like, psychologically just a very bright idea, but not workable. First is that you should be in a position to define what you are actually trying to work on, and then work all the way from measuring it, analyzing it, designing it, and verifying it. So that is where you actually run your prototype to see that whether it is uh, giving the right kind of input, right results or not. So and it's all about always remember that it's all about uh, having a continuous improvement. And though the world is not linear, understand, though we try to uh, most of the time when we describe things, it's easier for us to understand when things are given in a linear fashion. But understand, life is not linear. ठीक? And there is where we have to actually look into the non-linear aspect of it. And the same is true for design thinking also. Whenever we want to develop a prototype, these are the steps which are involved: empathize, define, ideate, prototype, test. If you have understood till what we have learned, what we have explored just now, a few minutes back, I am all trying to develop some kind of logic. Empathizing is all about defining your problem. Okay, so sensing, pre-sensing that there is some kind of problem or issue which is needed to be addressed. And from here, you define. So, but my idea is not just to give you that these are the 1, 2, 3, 4, 5 things which are there. More important is look at these arrows. Okay, it's not like that strictly this has to flow in this direction. Empathize, yes, there is someone else, there are people, has to be something to be done on this front. And then you pick up that project, you define it, and then you say that, okay, this is where my problem is, this is how I am going to define it, these are my variables. I want to see that whether my ideas are working well or not. You develop a prototype, and from those prototypes, see this, learn from prototype to spark new ideas. So prototype in itself is not the end, it is actually the beginning. Always remember that this is also. And then finally your test. So test creates new ideas for the project. So as you could see the links, so from test you could see that there is a link to ideate, and there is a link to define, and there is a link to empathize. Everything. So this shows that there is a continuous cycle. You should stop looking things in a linear fashion and try to see more in terms of circles. If you try to look life in circles, it would be worth, and it would be more fascinating to look at world than it is looking at world as a static place. For example, if you see networks, right now, networks are very important. And in networks, what you see that there is whole lot of connections. There are nodes, and nodes, when you say that nodes, that all the points from where the communication is starting or reaching to a point, these points are what? These points are nodes. And in a networked world, always remember that no matter what happens, there are some nodes which would be more important than rest. This is how world is. It will happen every time. And if you could also see, if you could also find out that how to work, and in a networked world, the beauty is that you are connected to millions and millions of people. So it is far easier for ideas to move from one nodes to another in a networked world. And yes, network capability says that there would be some places which are more uh, what you say, rewarding for the kind of efforts you put in. Because if you see, this is the idea of networks, that there are certain places, there are certain nodes which are more important than rest, and then there is more of sharing, more of widespread adaptation which is taking place. And because we are living in a networked world, that is why there is the other thing which comes into play, that um, the moment you got some idea, and should I go for a patent? As soon as I get some idea, I saw that the logic is so beautiful, it is connecting, and scientifically, it is it can be, you can present it to scientific community, and there is no and but you think that, look, okay, let me wait for a while and do go for prototyping, and then I will file a patent. I don't think that is a right approach. Why? Because, and it is not like that I am saying it from my own experience. You would see it that lot many uh, institutions are there, and organizations which they emphasize on that no matter how bright your idea is, and no matter if you are the one who originated it, it is all about first to file and not first to ideate. Always remember this: first to file. If you get some idea and it is so pressing, go for patent. Okay, if it requires, yes, prototyping, you could come that, sir, I do not have prototype, let me have prototype first, let me run it, and then I would register. No, it's okay. I would suggest that it's always a better way to patent your idea first and then go for prototype. You could do it either ways. No, not, nobody is stopping you. Prototype is giving you even more marks. Will definitely, once you will get into this, let me patent my idea, you have to see it. You will see that they would ask that whether you have run a prototype or not. But yes, you could say that yes, we are in process of developing it, we are running it, we are running multiple prototypes. So that is a one way. Because ultimately, always remember that first to file, because that is something which is a technical requirement. So one has to think from that dimension. Okay, and in a networked world, ideas spread faster than anything else. Okay, so that is the power, or that is the limitation, whatever the way you would like to call it, it is there with the world. So yes, this is, I have covered it. What this prototyping offers designers the opportunity to bring their ideas to life, test the practicability of the current design, and to potentially investigate how a sample of user thinks and feel about a product. So, well, how practical your idea is, who will tell? Your prototype. Okay, how it feels, how people would like to use that product, what kind of offerings that product will have, what kind of all these things can be learned by prototyping. That you should not stick to a linear way of looking at world, and the same is true for prototyping also. Okay, these five things will help you, but you have to think that it is not a linear, rather it is a continuous process made up of multiple loops. Now I am taking you to some very interesting ideas, that how people uh, fail to think differently, and they end up coming up with mediocre products, or offerings, and try to understand that why thinking right is important. Okay, so let me introduce you to this idea of single loop and double loop learning. Okay, this is again a very practical tool. Let us try to see if you could see that there are three balloons: beliefs, actions, and results. So if we see, if we only focus on action, what we do and what we get, if there is, if if our concern is only about this, that we have some time tested ways, we do those interventions and we see result. Is there any gap filling exercise, and then this is done. Now this is called a single loop learning. Whereas before even actions, before our action, from where our action emerges from some set of belief systems. And this is the real question, why we do something. Okay, and most of the time, I repeat, most of the time these beliefs are taken for granted approach, are just they are not challenged, or they are deep down beliefs of how we perceive our world. So sometimes, unless, if this is so static, if our beliefs are so static about this world, students, please focus. Now I am speaking about the real thing. Like, if beliefs are so static, then we are not going to innovate anything new. We have to develop certain ideas of challenging these beliefs, because these are anchors to, these simply do not allow us to try doing something else. Let me take you to a very important concept of mental model. Mental models are the way we look at our world. The whole world, as we see, we all have a mental representation of the world we live in. This is how the world is. The lens through which we see the world, that drive our responses to everything we experience. Being aware of your mental model is key to being objective. Okay, let me tell you that mental models, what are mental models, and why they are important for us to discuss today. Look at this statement. If all you have is a hammer, everything looks like a nail. And this is very important, that mental model actually works like this only. So we are so convinced about our realities that we do not try to question underlying beliefs, underlying assumptions. So we never see, we are doing something in a certain way, but why we are doing, we never bother to ask this question. Let me take you to this example. What you could see is a child's toothbrush. The whole industry thought that, you know, child's toothbrush is just a matter of size. And engineers, this is especially for you, try understanding that the whole industry was sharing the same mental model. Understand, mental model is not just like the individual is sharing. Sometimes the whole industry shares the mental model, the same kind of mental model, the same set of assumptions. So they said, it's just a small form of wind. Afterwards, that they conducted this research, and they saw that the small babies or small kids, their fingers are small, and when they try to hold this small toothbrush, it slips away because of its poor design. Why poor design? Had it been made for an adult or the way adult toothbrush are made, it is fine. You could hold it properly. But a child's finger is small, and then he want a greater grip. So, but if you continue with this same old mental model, that what a child's toothbrush is just as a form of a small form of adult toothbrush, then you will never be in a position to solve the fundamental problem. So this is what happens when single loop learning happens. So people say that okay, I have certain strategies and techniques to do, and results. Okay, okay, children like color, so make some colorful toothbrush. So you are not addressing the problem which the kids are actually facing. Their fingers are small, and this is small, and and the toothbrush is slipping away. So what is the remedy? The remedy is this, as you could see, that when you start working effectively on mental models, that a child would rather grab a toothbrush with a wider base, with a better grip, wider grip. So then that makes brushing easier. So what's happening actually? Why I am trying to, why I am giving you this example? Because that you should be aware of your mental models. Like something, if your mental model, is it helping you invent something, or is it coming in the way of your invention? Are you getting what I'm saying? Like your mental models could complement your journey. You could take you to a greater heights, and it could also lead you to poorly designed product. And that is why, and in engineering, we call it ergonomics, right? So we should have the proper things should be easy to use for any users. So as an engineer, you have to be working, you have to be not just aware of your mental models, but you have the key to effectively working towards it. Now the same mental model uh, problem was there with uh, US automobile industry. So it so happened that in US, people, the whole industry thought that cars are primarily status symbols, and there were big three automobile manufacturers. You have General Motors, Ford, and Detroit, and the whole companies, they just saw they were too big, and all the patents, if you could see, they are in name of General Motors, Ford. If you could see the look at the manuals of automobile, you will find it. So they became little egoistic in terms of deriving a knowledge. They said that cars are primarily status symbol, and if you want better cars, you should be ready to pay for it. A high quality car means an expensive car. They failed to recognize that there was a company naming Toyota which entered in the US market late. I am talking about some 5 6 decades back. What happened when Toyota went there? Toyota said that ultimately cars are just means of transportation. It is just a means to commute. Uh, so they worked on those mental models that uh, cars are means of commute, and a quality car should be there at place because people should feel safe. Actually, they should travel safe, right? If the quality is compromised, then there could be repercussions, and repercussions would be very dramatic or difficult for everyone. So they came up with this mental model that cars are not primarily status symbol, they are a means of transportation. And they carved out, they continuously worked the way forward in cost reduction techniques and value creation. So constantly they were able to build more and more value at lesser cost. If it is costing them less, then definitely their cars, the price tag of their cars would be lesser. The same thing happened when the big three failed to notice that within a year, Toyota's market share rose up to 9%. And by the time they were able to realize that Toyota is a threat to them, Toyota is already governing more than 57% of their market share. See, this is the power of mental model. So why I am stressing on this? Because prototyping leads to product, and you should arrive at best product, right? So this is where the concept of double loop learning comes into play. Single loop learning is all about the strategy is what we do and the result what we get, the difference between the two. Double loop learning is more than just fixing the problem. This style of learning questions the underlying assumptions and values and beliefs behind what we do. So just scratch a bit and see that what are the assumptions which you are having. Isn't it that some assumption, let me show you something more. Yes, look at this. Means of communication. We communicate through different means, and we have this. I have intentionally put this. You could see that the telephone which was invented by Graham Bell and to this modern age phone, if you could connect that originally there was only one variable and that was voice. So what kind of changes you could see in the design of phone? That yes, there could be, buttons have taken place, and then as VLSI and more semiconductor, what you say, advancements have taken place in electronics happened, and then your phones started getting smaller. But look at this, we we always have this mental model of buttons carried for a very high for continued for decades, right? It was like that. Okay, so arriving at a modern days smartphone where we could see that communication not just means voice, but it also means picture, it also means text, it also means so many things, multimedia. So so from here to multimedia, your aspiration to communicate at a larger audience, so your devices should reflect, should has it in it to deliver your the expectations. And see, this mental model carried for so long that even if the companies like BlackBerry, they develop, they have that thing. Every other business people at strategic level, they used to have that BlackBerry phone, but it all came with this buttons, and the industry was so very preoccupied with this notion that we do not require buttons. Also buttons are also some kind of logic which is not, you are do not require them, and it is unnecessarily it is eating up your space, so much space where you could devote it to a screen to make the screen larger. And today you have seen it. So try understanding that this is the place where you have to think in devising your prototypes, right? how to think that is more important for us. So this is something for you all. Now, uh, for participants, wait a minute. Okay, so what about, do we have something? Uh, I have developed an exercise which you could do it uh, for what kind of prototype is important and how to go about it. Where should we start with? So you could take some key takeaways, like uh, there is a whole lot of things which are there in society. People uh, in remote areas or villages, if you see, we do not know that what kind of problems they are facing, and the world is so diverse, and so many things are there where so much of opportunity lies for you to actually uh, start uh, devoting your time towards taking up some project for social entrepreneurship, especially uh, all the engineering students. They should come up with such instances where um, there are different projects, like you have waste management, when which is waste management is something which is there with every other city is facing a lot of problem. So how can we, do we have any innovative solutions for, for this, how to address this waste, solid waste? You have different kinds of projects which you could take up in solid waste management, water sanitation. Small ideas can really spark a lot of changes. You see, there are cases where people with very small investment, they were able to uh, make a very big difference to the people around, to the communities around. So this is where I want you all, you could take help from your faculty members, and there are different websites. um, you could just Google it, browse it. Today you could just write few uh, uh, terms like some social enterprise and projects in social enterprise for engineers, and you could see a whole lot of list is populating. So you could come up with, you should try to bring that change. Being there to give your right support, give your helping hand. Okay, be the one which everyone count on. And there are people, there are communities, there are group of people who really want certain help, and you earning, you have an engineering degree, but that is just your qualification. Your real goal is to bring a visible change in their life. How you are going to do that? Okay, so many students, I have seen it, they have came up with water filters and how to uh, make the water potable uh, by using some small, not very high funda physics, small physics. I remember there was an entrepreneur who actually used this technique. You might have seen it in aquarium, that there are bubbles which used to pop up, right? In aquarium, in fish aquarium. And what happens actually, that with when this bubble pops up, uh, it bursts. And so he was very particular. He was very curious to know, that student, that this looks so beautiful. What is the use of it? So they said that okay, this is a simple technique. Uh, when this when this bubble pops out, the bacteria is there, whatever is there is going to be killed, right? And it's a simple physics. He used the same principle to instill, to come up with a product, and he went it I don't remember his name right now. He Maharashtra and
हाँ ठीक है
Gujarat,
मैडम आप बंद कर लीजिए
and
कैमरा.
people were able to, and this was a remarkable thing. He used this technique, and it just costed. You see, once this system is get installed in in a hand pump, it is going to last for 20 years. Look at the value. Simple, very simple, but very practical idea. And you know what was the impact? Once villages started installing this product, the uh, people who used to get infected by different waterborne diseases, right, like dysentery, um, or typhoid, they it showed a sharp decline in that. So it actually helped. By using a simple principle, you could do that. There are different kinds of innovations, which where you could actually try building some prototypes like solar pumps, uh, and uh, how to preserve water, making some kind of biodegradable plastics. And there are different ways which where you could use it. Now there was a company, there they started making soaps. The soap bottles were used to be made up of uh, plastic. So once they are that shampoo or that soap is over, you will throw away that thing. So some people tried this, that they came up with an idea that after there is some kind of coating which they did in that bottle. Once the shampoo gets over, you can use that thing, that foil, as a soap, and so there is no wastage as such, right? So there are different ideas, there are different ways. People are trying these small prototypes also, and then coming up with real products, real way. So that is all from my side, and over to the organizers. Thank you very much.
Thank you so much, sir, for this wonderful session. And I hope our students, along with all faculty members, dear faculty members, must have learned so many new things, new perspective about this prototype process design to development. I would like to ask few more questions that has came from student sides. May I ask you questions, sir?
Yes, yes, please.
One of the very basic questions coming from a student side is how to test a prototype. The basic thing about how to test a prototype.
Prototype. Yes, as I said, like the right from the basic, that once you have defined certain thing, you want it to behave in a certain way, right? You want, you have an objective to be attained. How closely, how beautifully you are able to cover that. That is the thing which you should talk about, that whether my prototype is moving in right direction or not, right? So if you suppose there is a if there is a if you are inventing a fan, I'm just giving an example that your engineering problem is to come up with a fan which consumes less energy. Okay. So now you are trying to come up with a prototype which consumes less energy. So you started reading certain technology. And let me tell you, there is a technology, BLDC technology. You use that technology, BLDC, and then you try to look at your prototype that yes, now this motor, which was originally consuming some 70, 80 watts, now it is consuming only 30 watts. So, which is a big dramatic jump from the same torque you are able to generate, by less power. So this shows that your prototype is working fine, right? So even like you should be in a position to constantly measure and see that okay, 50% reduction, 20% reduction, 10% reduction. What is the amount? What is there in your mind, and how closely that product is able to deliver? Yes.
Thank you so much, sir. That was a wonderful answer. Uh, One more questions from student. So, what is the process and how to get the prototype converted into patent?
How to get in convert into patent? See,
Yeah.
first of all, as I said in my in this due course that uh, the process, the technicality of patent is such that I believe that you should, the moment you get very convincing idea, you should register. You should at least register for a patent. You parallelly go for your prototyping testing. I have a reason why I am saying this. Earlier, many instances happened in past where people, just because they do not have a working model at place, which you call it as prototype, they uh, fail to file a patent, and their file got delayed because somebody else came up with the idea, and they filed the patent first. So it was, as I said, it was like not filing it first is more important. Okay. If you have, if you already have prototype, it is working fine. If there is just look at the time lag. If it is taking a lot of time from your ideation state to prototyping stage, better file a patent. If it is like manageable, parallelly it is working, and you are able to see that yes, your prototype is there, it is ready. So with those, what are the objectives? See your prototype is working, the key result areas delivered. If you are able to articulate it and give it in a technical presentation, a form of a technical report where patent filing you should, no, there is a prescribed format wherein you have to see that what are the new things, why the product is new, is it involving inventive step, is it involving inventive method, is it involving a new altogether new product, right? So there are different categories. So you have to draft your proposal in that way, and there are experts also. If you are not that is the problem. Look, people do not have that competencies at times. They do not have that those areas, that is the main thing, that they are not exposed to those areas. So professional help is also there. So one could take help of professionals and apply for a patent. And it is important not just to apply in India. If I could share statistics with you where you could see that if 100 patents are like if you people are filing more patents in India, and the same set of people filing abroad. So patent grant is more in case of foreign companies. So conversion rate is higher for if people are patenting outside the country. Why this is happening? Yes, lot many reforms have taken place in past few years, and is office and patent office is becoming, yes, it is responsive. You should, but it takes a lot of time. Some 18 months people have to go through, read it through, what is the inventive step, uh, and then it is about, the one word is intellectual property. So for intellectual property rights, there are, you have to, the whole world is your, is the platform. One should not restrict yourself to just one country, um, and think beyond. That's the way.
Thank you
Sir, I
so
have
much.
one question. Sir, I have one question. That suppose if someone has a one prototype, so can I improve? Can I register that prototype in a patent if I improve something in that prototype? Is it possible? Hello, am I
Hello.
audible? Audible, sir?
Yes.
Sir, suppose you have a one prototype. So can I,
Yes.
if I improved, if I made a one improved version of that prototype, so can I
Yes.
register that prototype with my name as a patent? Is it possible?
See, improvement, the improvement in your own existing prototype,
Other person prototype.
there is some issue regarding that, right?
Okay.
See, you have, if it is your own, then you could do that. There is no end to it because it has ideated from you, and it is just a process. That's what we have discussed so far.
Okay.
But otherwise, not.
Okay.
Sir, another question from my side.
Sir, please,
Sir,
sir.
actually, I got so many times, one of the questions from the student, that is
Uh-huh.
the project and prototype. These are the two
Uh-huh.
basic words. When I'm talking about the BTech engineers, only the engineers I would say, or the if I'm talking about the researchers generally use the prototype, and
Right.
the BTech students use the projects.
Right.
So how the, because our audience is basically a BTech students, so
Hmm.
how the students can be correlate the both words with our the major projects inventions. These are my this is my the question, sir.
Okay. Okay. So basically, when we say keep, there is a project, as students, do you have to do some kind of project, which you have to, and what they do in that project is more or less the same, because they have to uh, they have to come up with an idea, they have to run a prototype, simulation, and then they have to come up with their findings. Yes, so it is more like, it's nothing like, it's more like an academic way of dealing with something, and that's the way I look it at. And students should not see it as a different thing, because ultimately project means that it is a time bounded uh, activity with certain objective, certain thing, certain goal in mind. You have, and it is very much anchored. You have your timeline, you have your Gantt chart, you have everything at place. uh, After this thing, my project is here, what is the stage. So there is actually, I mean, we use that term interchangeably, project and prototyping, but ultimately you are doing the same thing. As an engineer, the task is that you are becoming more and more familiar with the tools and applying what you are learning. So theoretically, I mean, presentation point of view, it is in a form of a report, but yes, you have to show it somewhere that it is working in real world. It is prototype only. That's it.
Okay, sir. Thank you.
Thank you, sir. One more question I would like to ask.
Yes,
Uh,
sir.
Actually, what are the biggest challenges that are associated with product design?
Biggest challenges with product design, as I
Yeah.
said, product design always begin with what your customer wants, right? This is a something which is a very beautiful strategy. People say it like, what is that, what your customer expects from the product, or how would you like to, who is going to be the end user. From there you pick up those points and then try to bring it into your product, the features of the essential features of your offering. See, when we, as I said, that our, what is the challenges, the challenges is our mental models. Sometimes we are not aware that we might be giving uh, a wrong solution to a right person, right? Because what is happening ultimately, that we are so focused on the notion of let us do it all together in a different way. Our way of looking at product is simple, or could be limited. This could be a challenge. As I said, like for years, for decades, this thing continued, that people do not able to conceptualize that okay, a phone screen, there has to be some buttons to push. Otherwise, how could be there be a phone? There could be no phone because if there are no buttons attached to it. So it took a lot of time for industry to give up this idea that yes, it is a very logical thing. We do not require it at first place. So this is one thing. And customer, like what customer ultimately wants, from then you try to go backward and see that where all, what all values can be added, what all can be accommodated, what all can be done at practical levels. Like, and then there is always a list of things which always allow the natural inclination of engineers, like cost reduction. One very very important thing, look out for something which you could do it for a better way, a devising a product which maybe sometimes your manufacturing facility, you just do a little change here and there. There are some unnecessary steps which are carried forward. Why? Nobody knows, because it is ritual, it is happening for decades, for years. Nobody knows what is the logic, but people carry it on forward. So that is where we have to stop. We have to actually look at every product in a fresh way. And today is the best time when we are actually in a state of uh, multiple disciplines are coming together. Your arts and science are coming together in a better way, in a much meaningful way. So that is why we have to harness that this opportunity. So this is where I think, and design is something which you have to, like, design is meant to deliver some key idea. So answer is all would be there. Am I able to deliver my idea? Am I able to deliver that promise? If answer is yes, then my product is good. If answer is no, I need improvement.
Thank you so much, sir. That was really a wonderful session and altogether a very fruitful interactions with you. And I'm hopeful that our students and many of us have experienced the shift of paradigm regarding this topic, this subject. Now we are heading towards concluding session. Dear friends, for that, let me request and invite Dr. Viva Srivastav Madam. She is Vice President, IIC Sisteki, Ratibad Campus. Viva Madam, please.
Thank you very much, Pankaj sir. Respected our most eminent speaker, Dr. Ashutosh Shukla sir, Principal Dr. Manish Billore sir, Mr. Ashish Singha sir, President of IIC Sisteki, and my teammates. Good morning to all. On the behalf of our institution, I extend a very hearty vote of thanks. A very big thank you to Dr. Ashutosh Shukla, sir, organizing a wonderful workshop on prototype process design and development. Sir, we are really enlightened, and with your knowledge and presence. Thank you very much, sir. I would like to thank our director ma'am, principal sir, for their wholehearted support. And very special thank to the organizing committee members, Mr. Ashish Singhal sir, Pankaj Sharma sir, Ayush sir, Pankaj Mantani sir for their unflinching conduction and coordination. And many thanks to our audience also. Thank you very much, sir.
Thank you, sir. Thank you.
Thank you very much.
Thank you, sir.
Thank you